Alright everybody, this is going to be the last video in a series of videos on properties of limits. The last two videos specifically we're looking at how you apply properties of limits, the sum rule, difference rule, power rule, quotient rule, all those rules. And we're essentially using either a graph or a table to do it. Well, here we're going to be doing it a little bit more analytically, and we're going to be working with function f and function g, the two polynomials that we see here. So the way that I would expand and evaluate the statement that we see here, just this one right here, the way that I read that is I read it as we're going to take function f and then we're going to evaluate the limit of function g as x approaches a positive 2. So what we do when we see that is I'm going to say f of, and now I'm going to take function g, the negative 2, and I'm going to evaluate it for a positive 2. And that will give me f of negative 4. Well, now I'm going, just using my normal function notation, I'm going to evaluate f of negative 4. So I'll say f of negative 4, and anywhere I have an x, I will substitute the negative 4. So I'll get negative 4 cubed minus 4 times negative 4 squared plus, oops, and I'm writing that down wrong, let me fix that, minus, and in parentheses is negative 4 squared, and then plus 4 times negative 4 and minus 1. So the negative 4 cubed will give you a negative 64, and then negative 4 squared will be a negative 16, or I'm sorry, a positive 16, but we have a negative in front of it, so that'll be a negative 16 here. And then I have a minus 8 and a minus 1. So negative 64 minus 16 minus 8 minus 1 is not the number I expected it to be. That's because I multiplied wrong right here that some of you probably recognized. This is going to be a negative 16 also. So let's do it, put another negative 8 there, and that will equal a negative 97. Okay? So, arithmetic error aside, that is how you will substitute or how you evaluate a composite of two functions. So at this point, I'm going to go ahead and ask you guys, we'll turn to the next slide here, and I'm going to ask you guys to go ahead and do the other way around. So evaluate function limit of g of f of x and as x approaches 2 and see what you get. So go ahead and pause the video now, work it out, and come back and hit play when you're done. Okay, on this one we're going to be evaluating function f as x approaches a positive 2. And I don't remember where I had my stuff. There we go. So we evaluate function f at a positive 2 and we get an 11. Well, that 11 is going to become the input of function g. So I say negative 2 times 11 and I get a negative 22. Now the last composites that we're going to be looking at here, we're kind of going to be doing it back from a graph. We're going to be looking at these two piecewise functions, function f and g. They're different than the f and g that we saw before in piecewise functions. But here we're kind of just going to be looking at the evaluating here. And again, I'm going to do A for you as an example, and then I'll ask you to try and do B, C, and D and see how you do. And so function f, I'm going to, well, part A, I'm really going to evaluate function g as x approaches 3. And when I do, let's see, so as x approaches 3 on function g, that gives me a 1. So the input of function g, or the output of g, becomes the input of f. So now I'm going to evaluate function f at a 1, and that puts me at a negative 2. And this is how I have it typed up somewhere. There we go. So at this point, guys, go ahead and pause the video, work out the last three, and when you're done, when you have your answers, come back and check your work with mine. Alright, so hopefully we have some good answers here. Let's take a look at function F, or I'm sorry, part B. Let's just look at part B. Part B was a little bit challenging because when you evaluate function F, you're going to get a number that the input of function G you don't actually see on the graph. I believe it was a -6. And you don't see -6 on the graph, but you can do a couple of things. You can simply use the slope of the absolute value that you see there, or you could write the equation of the absolute value, the transformed function, and that's what I did. But either way, hopefully you came up with a -7. And I'm going to just go ahead and do D next, because D follows the same kind of pattern. You're still going to be looking at the absolute value where you didn't have somewhere. There we go. That one should also give you a -7. So I'm using the same transformed function to help me, simplify that one. Now, function C in class, a lot of times kids are going to say that the limit here doesn't exist, and I understand why they say the limit doesn't exist. Because when you evaluate function G at a +1, you can see that it is discontinuous. So the left-hand limit and the right-hand limit don't match, and so if the limit there doesn't exist, how can there be a limit for the composite? Well, this one's a little tricky. So it is discontinuous at x is equal to 1. However, if I look at the left-hand, right-hand limits, the -1 and the -3, I can substitute those two numbers into function f and see what I get. And it happens to be a parabola on function f where I'm looking at it, which of course is symmetrical on the left and right sides. So even though part F or part G is discontinuous, if I take the left and right hand limit values and substitute it into function f, I do get the same number. Therefore, the limit of that composite will be a -6. And that's going to wrap up our lessons on properties of limits. I hope you learned something, and I hope you are better prepared for the upcoming assessments. And if you have any questions on anything, please don't hesitate to contact me. Come see me for tutoring, whatever you want to do. But thanks for watching, everybody, and take care.